I'm Nick Feemster. I'm going to give a brief talk on our work on mining DNSBL queries. My co-author here, David Dagan, is sitting right beside me, and my student Anirudh Ramachandran did a lot of the heavy lifting here. This was just a fun little study that we did with seeing basically what we could mine out of the DNS blacklist queries. The idea from this for this study actually came from a piece of spam mail that David got. As you know, we've been doing a bit of research in spam, and we actually read our spam from time to time. So we got this idea from an email that David had, where a botmaster was selling a fairly large bot, and it said, rent out this set of bots for a certain amount of time, $1,900. All the IP addresses in this botnet are unlisted in blacklists, and we thought, that's really interesting. How do they know that they're unlisted? Of course, they could be lying, but assume for a minute that in fact they know what they're talking about. Well, they've got to have some way of figuring this out, right? So we thought, okay, well, perhaps these guys are actually looking up the status of the bots in the blacklist. So let's go look. Let's use this as an opportunity. Can we actually mine the DNS blacklist queries to reveal this kind of reconnaissance? So this is probably a little different than some of the DNS blacklist studies you've seen before, which are looking at perhaps what's actually in the blacklist. Here we're turning things on their head a little bit. We're looking at who's doing lookups to the blacklist, and can we get information about bad players from who's actually doing the lookups. So that's, in a nutshell, the insight behind this little fishing expedition. Of course, there are lots of legitimate lookups coming to the DNS blacklist. So the key challenge is actually, how can we figure out in this huge mess of queries, what queries are legitimate queries, and what are what constitute this reconnaissance activity. So we're going to basically develop some heuristics on that. They're not perfect, as you'll see, but even using some of these heuristics, we found some pretty surprising things. There's a paper on this which you can get. It's linked off of my webpage if you just Google for that, where we also talk about temporal properties. But most of our study focuses on these spatial heuristics, which I'm going to describe next. So as I mentioned, this is not perfect because large ISPs obviously use different mail servers for inbound and outbound traffic. But there are hacks that you can do to sort of account for that as well. The basic idea still applies. If you consider the inbound and outbound mail server as a single node, if you know what those IP addresses are. The idea is very simple, actually. The heuristic relies on the insight that if you have a legitimate mail server or set of mail servers, that server or group of servers is going to be both the subject and the target of DNS blacklist lookups. That is, it's going to be sending and receiving mail, right? Because when it receives mail, it's going to perform lookups to the blacklist, and when it sends mail to other people will be looking it up. So there's sort of a symmetry going on there. In the reconnaissance case, in fact, what we were looking for was a lack of this symmetry. That is, a host performing reconnaissance will be doing lots of lookups to the blacklist, but will never get looked up itself. So that was sort of what we started out looking for. In fact, when we dug a little deeper, we found some more surprising things. But that's sort of the basic insight that we use to sort of tease apart legitimate queries from reconnaissance queries. So this is sort of the basic measurement approach. We have a very large spam house mirror at Georgia Tech that David has been putting together that we used for the basis of the analysis. We then constructed this graph of who's querying whom. The graph is giant, so that's actually part of the reason we're in the research forum. I'll get to some of the difficulties at the end, but we needed to sort of prune it to see if we could get a subgraph and start looking for anything interesting in there. So we pruned it actually by looking first at like for some of these nodes that we know were interesting, IP addresses that we knew to have been involved in some botnet activity previously. And then we looked at what nodes in this graph had high out degree, that is, what nodes are sending a lot of queries to the blacklist that are not actually being targets of queries themselves. So this is just a graphical representation of that. So basically this is the spatial heuristic we're applying. For every edge where some host A is sending a lookup for B to the DNSBL, we're adding an edge to this query graph, and then we're extracting nodes that have this high out degree to in degree ratio and looking to see what we find. There were three things actually we sort of thought, okay, if we were doing this reconnaissance, how would we do it? Well, of course, the 5 seconds of thinking would get you to this first approach, which is, we call this third-party reconnaissance. This is basically just some dedicated machine just pounding a blacklist. Of course, this type of thing, we sort of expected to be the predominant technique. Hence the heuristic we developed, right? I mean, this is exactly the kind of thing the heuristic would pick out pretty well. We did see some of this. There are a couple other techniques. The 15 seconds of thinking might get you to the second approach that we started looking for, which was a sort of self-reconnaissance approach, which says, well, you've got a lot of things to look up, all these bot IP addresses, but you may also have a botnet, so why not just use the botnet to start doing lookups on these IP addresses? Distributed computing, cutting edge. So this we did not see very much at all. In fact, it's a really dumb idea, right? Because you know, a machine looking up itself, that's never going to happen in any legitimate case. It's very easy to detect. So unsurprisingly, we didn't see a lot of that. This third approach, which actually when we started this work, we sort of thought, okay, this is probably something that as these guys get more clever and as this heuristic gets published, the bot masters will move on to doing something like this distributed reconnaissance, where you actually distribute the workload, have bots look up, other bots in the same botnet and other botnets, etc. And actually, we very surprisingly witnessed evidence of this. We were really surprised to see this. Let me sort of show you what we saw here, actually. So, if you remember from NANOG 37, actually, I talked about a large spam hole, spam sinkhole database, spam sinkhole data feed that we used to do the spam and BGP hijack data. So this is actually the same data set that we used in this study. So what we did is we have two sets of IP addresses, right? We've got a set of IP addresses that we know are hitting our spam sinkhole. And actually we pruned those first down to the intersection of IP addresses that were hitting our spam sinkhole that we knew to be botnets. Okay, so now we've got a bunch of IP addresses that we know are botnet IP addresses that are spamming our sinkhole. Then what we actually, the second set of data that we had was, of course, the high out degree nodes. That is the set of nodes in the spam house trace that were sending lots of queries to the blacklist, but not getting queried a lot themselves. What we found, rather surprisingly, was that some of these high out degree nodes, which I've shown on the right, were actually there were edges going into the bot IP addresses that were spamming our sinkhole. Those actually were not bot IP addresses that we actually knew about already. So that was actually probably the most surprising finding that we had in this little study, was that sort of by taking these two data sets and linking them together, you can actually start with some small set of things maybe you know to be bots and actually bootstrap up to get a larger set. In the middle of the slide here, I've shown basically some of the I've removed the IP addresses to protect the guilty, but those are the ASs in which we found nodes for that had very high out degrees, and in fact, the in degree of all of those nodes there was 0. So this is basically just a CCDF. It's a little tough to read, but the main point is what I've drawn out there with the arrow, which basically shows that 90% of these nodes that we see are only issuing one query. So even it is perhaps the case that this simple spatial heuristic that we've come up with may need to be refined, because in fact it looks like these botmasters are actually quite sophisticated already at distributing these types of reconnaissance queries. Okay, what does this all mean? We were really surprised, actually. I mean, this is bad news. These guys are way ahead of us. We had sort of speculated on how we first weren't even sure that this reconnaissance was going on. We figured it might be. Worse than what we expected. Not only is it going on, but there's some pretty advanced techniques that these guys are using to perform this reconnaissance. There's a flip side to the coin, though, and that's that there are some spatial dependencies in this graph, right? So we could, if you've got two data sets, for example, if you start with something like a spam sinkhole, like I showed you before, it's possible to, for example, maybe mine the query graph and see, well, we know these guys are up to no good. Let's look at who's querying the blacklist, and who, are there any other nodes querying those nodes that we know are up to no good, and perhaps that tells us something about those. So that all sounds really, really easy to do. But there are a few problems, of course. And those are that's again, as I mentioned, as I alluded to, why we are in the research forum. Figuring out exactly how to mine this query graph is pretty intensive, both computationally and in terms of storing the graph. It's just massive. As I mentioned, we did some sort of hacky pruning to get it down to a size where we could look at a piece of it that we thought might be interesting with high likelihood, but actually doing what I just said in terms of like taking a small set and bootstrapping up using the query graph turns out to be a lot harder than it sounds. Although it's certainly true that starting out with some pruning techniques may be promising. So that pretty much concludes my talk. I'll take some questions if there's time. Thanks. There's also a 6-page tech report or short Shruti workshop paper on my homepage. You can actually get more details there.
Nick Randy Bush, IIJ. I have a fear that too few people use spam prevention techniques such as DNSRBLs, and one indication might be what proportion of the queries, total queries, are represented by botnets proving they're clean? Is it significant?
You're saying what percentage of the total queries are this type of reconnaissance?
Right.
Very, very low.
It's low.
Yeah.
Okay. Thanks.
There seems to be some general interest in fingerprinting requests. I don't know if that's possible for the querying in this particular case. Would it make sense to see if there is a pattern and a particular fingerprint of the query to the blacklist to see if one can identify the evil from the normal queries? Or they're essentially the same, undistinguishable queries?
You're saying, are there other heuristics or properties that we can perhaps use as features to distinguish the legitimate?
Yeah, because they're presumably all running the same version of the software.
That's possible. They may be running the same version of the software, and that might be something to look for. We haven't.
Is there any? I'm sorry. Go ahead.
Oh, I was going to say there are other things. I think that also we might be able to look for based on the fact that legitimate queries are driven by actually emails being sent. So there might be a fingerprint for that that we could say, well, these follow a pattern we'd expect, and the rest are.
The second follow-on question, is there any temporal correlation between these queries? Do they just kind of randomly pop up over, or is there kind of I just got myself a new botnet, I need to do the query, and then I don't, because there's really no need to do that repeatedly like you would do for email?
That's a good question. I don't have an answer to that. Maybe David has looked at some of the follow-on temporal correlations. But we didn't study the temporal properties in this.
So the intuition we gained from trying to reduce some of the data is that a technique such as bucketizing and putting things into epochs really don't reduce this volume of the data. And this indicates that there's a very low and slow pattern being used. In other words, an individual bot might do just a handful of queries over the course of an entire day. And this tends to match some of the patterns of spamming behavior that we sometimes see for spam bots that send out just a small number below a threshold that an ISP might be patrolling.
Yeah, just to echo that point, the low and slow thing does show up in the spam data that we see as well. There's a lot of this both in the reconnaissance and in the spamming that's clearly explicitly designed to slip under radars.
Thank you.
Thanks.
Just a momentary note, sorry to barge in again, Randy Bush. When you've got 100,000 bots and you're testing 100,000 addresses, each bot does not have to do very many.
Exactly.
Yep.
Exactly.
Okay, our next speaker is hopefully here somewhere.